Question 2, part A, we need to find dy dx. So we've got y is equal to 15x to the power 3 over 2 minus x to the power 5 over 2. So dy dx is equal to 15 multiplied by 3 over 2, which is 45 over 2, x to the power n minus 1, so 3 over 2 minus 1 is 1 over 2, and then minus 5 over 2, x to the power n minus 1, which will be 3 over 2. And because we're looking for a maximum point, we need to find dy dx equals 0. So what we could do here, we could multiply both sides by 2 and then factor out a 5x to the half. So I'm going to do that. I'm going to take out 5x to the half, and we've got left 9, because 9 times 5 is 45, minus, we've already taken out the 5 and got rid of the 2, and we're left with x to the power 1, and that will be equal to 0. Now we're already given that x is greater than 0, so x can't be 0, so therefore we've just got left that x is equal to 9. Now when x is equal to 9, we need to find the y value, so y will be equal to 15 x to the 3 over 2, or 9 to the 3 over 2, is root 9 cubed, and root 9 is 3, so 3 cubed, and then minus root 9, which is 3, to the power 5, and that gives us 162. So we've got the coordinates of the maximum point, 109, x is 9, y is 162. Now we're asked to show that that's a minimum, so we need to find the second derivative, d2y dx squared, and we need to go back to our expression for dy dx. So when we differentiate again, that's 45 over 4 this time, so we've multiplied by a half, x to the power minus a half, minus 5 over 2 times 3 over 2, which is 15 over 4, x to the power n minus 1, which is x to the power a half. And we need to substitute x is 9 to find the second derivative, so d2y dx squared is equal to 45 over 4 times root 9, which is 3, so 4 times 3 is 12, and then minus 15 over 4 times by root 9, which is 3. So we've got 45 over 12 minus 45 over 4, which is minus 43 over 6, which is less than 0. So hence we've got a maximum point. And then question B, we're finding the tangent when x equals 1. So we need the gradient, so dy dx when x is 1 is 45 over 2 times root 1 minus 5 over 2 times 1 to the power 3 over 2, which gives me 40 divided by 2, which is 20. So we've got a gradient of 20, and we also need the y value when x is 1, and we've got y is 14 as that's given in the question. So now we can write down the equation of the tangent, and it's y minus 14 is equal to the gradient, which is 20, and then x minus 1. And just rearranging, we get y equals 20x minus 20 plus 14, which is minus 6, and that's our equation of the tangent.